Here we have a SAT math problem. Okay, let's go to the question. In the figure above, line segments OP and OS of sector OSP are ready, and the length of AC of rectangle ABCO is 10. If the measure of angle ACO is 60 degrees, which of the following is closest to the area of the shaded region? Okay, in the given figure, we have to find the area of this shaded region. Okay, my idea to solve this problem is to first get the area of the sector, this OSP. Once I get the area of the sector, I can subtract the area of the rectangle ABCO. When I subtract the area of this rectangle ABCO from the area of the sector, I'll be getting the area of the shaded region. Now, let me consider the information given. That is, the length of this line segment is AC is given, that is 10. Actually, AC represents the diagonal of the rectangle. Its length is 10. And also, we have the measure of angle ACO. So here it's 60 degrees. It's given in the question. Okay, so since ABCO is a rectangle, so the angle measured at each vertex will be right angle. So here we'll have a right angle at the vertex O of the rectangle. And now let's consider the triangle OAC over here. It's a right triangle. Here we have right angle. Here we have 60 degrees. And what is the measure of the angle over here? It has to be 30 degrees. Because in any triangle, the sum of the three interior angles must be equal to 180 degrees. We know that the right angle measures 90 degrees. This is 60. When I add these two angle measures, I'm getting 150 degrees. Then the measure of the third angle must be 30 degrees. So that the three interior angle measures will add up to 180 degrees. And also this OAC is a special right triangle. That is 30, 60, 90. Special right triangle. So usually in a 30, 60, 90 special right triangle, the side which is opposite to the smallest angle measured 30 degree is considered to be the shortest leg of the triangle. So OC is the side which is opposite to the smallest angle measured 30 degree. So this is the shortest leg, and usually we assume X as the length of the shortest leg in 30, 60, 90 special right triangle. The next longer leg is the side which is opposite to 60 degrees angle measure. And now to get the length of this leg which is opposite to 60 degrees, what we have to do is we have to multiply the length of the shortest leg X by square root of 3. Then we get X times square root of 3. So this is the length of the next leg which is opposite to 60 degree. Then the length of the hypotenuse is 2 times the length of the shortest leg, that is 2x. So this is the rule we have for the special right triangle 30, 60, 90 triangle. Okay, but already we know the length of the hypotenuse AC, that is given in the question itself, that is 10. So then we have 2x equals to 10. When I divide both sides by 2, I am getting x equals to 5. Okay, now I got the value of x. Let me replace this 2x by 10, the given length. And here we can replace the x, which is the length of OC, by 5. And here I can plug in 5 for x over here. Okay, now we have the lengths of all the three sides of this special right triangle. So here this is 5 and this is 5 times square root of 3. So we can consider the OC as the length of the rectangle and OA as the width of the rectangle. So using the length and width of the rectangle, we can get the area of this rectangle. Okay, and also we need to get the area of this sector. Actually, this sector is 1/4 of the circle, because here we have a right angle 90 degree. In any sector, if the central angle is 90 degree, then the sector represents 1/4 of the circle. So now we can get the area of the rectangle, and also we can get the area of the sector. But to get the area of the sector, we need the radius of the circle. So let me draw the another diagonal of the rectangle over here. That is given by OB. Let me draw it. So OB is another diagonal of the rectangle. In any rectangle, the two diagonals will be equal in length. That is, whatever length we have for the diagonal AC, the same length we have for the diagonal OB. Already we know that the 10 is the length of the diagonal AC. Then the length of the diagonal OB also must be 10. But this OB represents a radius of the circle because it connects the center O and a point on the circle. So clearly the radius of the circle is 10. Okay, now we have the radius of the circle. Okay, first let me get the area of the rectangle ABCO. Let me write it over here. Area of rectangle ABCO. So the formula is length times width. The length is 5. It's over here. The width is 5 times square root of 3. Let me write it 5 times 5 square root of 3. Then I'm getting 25 square root of 3. Okay, now I got the area of rectangle ABCO. Now let me get the area of sector. Let me write it over here. So as I said, the area of sector is 1/4 area times area of the circle. The formula to get area of the circle is pi r square. So I decided that the area of this sector is 1/4 of the area of circle, because we have the central angle 90 degree over here for the sector. So in any circle for a particular sector, if the central angle is 90 degree, that is right angle, then the sector represents 1/4 of the circle. Okay, now 1/4 times pi times the r represents a radius. We got the radius of the circle, that is 10. Actually, the length of the diagonal of the rectangle, 10 square. Then we get 1/4 times pi times 10 square is 100. 4 goes into 4 one times, and 4 goes into 100 25 times. I am getting 25 pi as the area of the sector. Okay, as I said earlier, to get the area of the shaded region, I have to subtract the area of the rectangle from the area of the sector. Let me write the stuff over here. So required area means the area of the shaded region is equal to, so first I have to write the area of the sector, that is 25 pi. From this, I have to subtract the area of the rectangle, that is 25 times square root of 3. So then I'm getting, so we can factor 25 out. When 25 is factored, we get pi negative square root of 3 inside the parenthesis. 25 times the approximate value of pi is 3.14. When I get the value of this square root of 3, rounding to 3 decimal places, I'm getting 1.732. And when I subtract this 1.732 from this 3.14, I am getting 1.408. Let me write it. It is 25 times 1.408. When I multiply these two values, 25 and 1.408, I am getting 35.2. Okay, now I got the area of the shaded region, that is 35.2. Among the given answer choices, one which is closest to this value, 35.2, is 35. We find that in answer choice C. The correct answer choice for this question is C.